What we mean is to make a comparative between the size of the specimen and the size of the image we are viewing in the microscope. So this is the point. If you have a specimen that is quite tiny, and you view it under a microscope and you're able to see very tiny microscopic internal details as large enough, and you're able to even appreciate things that you wouldn't have seen with your naked eye, that enlargement alone is what we call magnification. So by how many times that tiny thing has been enlarged for you to be able to see it, that is the magnification. So more technically, you can calculate magnification by using the formula. So magnification can be in terms of the height of the image over the height of the object, or the length of image over the length of the object. But then if you're using a microscope and you want to calculate magnification, you multiply the magnifying power of the objective lens that you're using by that of the eyepiece lens. So normally we have eyepiece lenses that are times 10. And so then if you're using an objective lens which is times 40, you multiply that objective lens power, which is times 40, by that of the eyepiece, which is normally times 10, and you get a magnification of times 400 when you're using microscopes. But then one interesting thing in the discussion relating to magnification is the subject of empty magnification and useful magnification. This is the point. So in a microscope, when you keep moving from one magnification to another, when you keep enlarging the specimen, you realize that from the very beginning, where the specimen is so tiny and you're using, say, the scanning objective lens, you don't see a lot of things because then the specimen is so small. Then you switch to, say, the low power. Then you begin to see new things because then you are enlarging the specimen, increasing magnification. So note that at that point in time, enlarging the specimen allows you to see things that you didn't see earlier. You continue to increase magnification and enlarging the specimen and keep seeing new things until a point in time where there's obviously nothing new that is coming into view. It's just the specimen that is becoming big. So things that are already resolved, or things that are already in focus or in view, are just becoming big and nothing new is joining the details. In this particular instance, we think that the kind of magnification, that is to say the kind of enlargement that brings along new details, is useful magnification. It is useful because it allows you to see entities that you wouldn't have seen earlier without magnifying. In the instance where you get to a point where further enlargement doesn't bring anything new, that kind of magnification is what we call empty magnification. It does not bring along any new details. Another interesting thing about magnification is the issue of parfocal. So if you're using a microscope, what you realize is that whenever you move from scanning objective lens to low power objective lens, you need to tune the adjustment knob of the microscope. You need to refocus. When you switch from low power to high power, you need to refocus again before you can be able to get a very great image, right? In such instance, we think that the microscopes are not in parfocal. Microscope objective lenses are said to be in parfocal when you do not have to readjust or refocus when you are changing magnification or moving from one objective lens to another. So when objective lenses are said to be arranged in parfocal, then switching from one objective lens to another objective lens does not require subsequent refocusing of the adjustment knob. And that is simply what parfocal is. And you should be able to know other things like parfocal distance, and which should be treated in subsequent tutorials. But I hope you found this quite helpful. Like this video, share, and subscribe to this channel for more interesting videos in future. Thank you.